Okay, so we're going to work with integer exponents specifically. We have three quick rules just to recap. When we're multiplying two exponents with the same base, we can just add their powers. When we divide two exponents with the same base, we can just subtract the powers. And when you have a power of a power, you keep the base and multiply the two powers, okay? But what I want to specifically look at is we have some negative values, okay? So I'm going to add a new rule to this. And essentially the rule is this. Say we have x to the power of negative a. I want you to think of the base as being like an integer. And we can make any whole integer into a fraction by putting it over 1, right? So if we want to turn this into a positive exponent, we invert the fraction, so 1 over x, and now the entire integer is to the positive value of that, okay? So I'm going to talk about a couple different ways we could solve this question here, okay? We're actually going to go into two different methods to solve this. I'll do the first one and then the second one on the right. On the first one, we go through these rules quickly, and on top we have two powers multiplied by each other, right? So their bases, we'll keep the same base and we add the integers. So negative 4 plus 8.
2.
Okay, great. And then on the bottom, I have a power of a power.
Wait, no, 4.
That's right. And I'm just going to multiply the two powers. Okay. So when we go to simplify this, we have 5 to the power of positive 4 and 5 to the power of negative 6. And because this is division, we just subtract the 2. We'll get 5 subtract negative 6, which is actually the same as writing 5 to the power of 10. Okay? Great. But let's say before I did anything, I wanted to actually make everything positive. Okay? So let's say I wanted to do that. We'll do it in blue over here. There's a second way we could do this. 5 to the power of negative 4 times 5 to the power of 8 divided by 5 to the power of negative 3 times 2. Okay? The first thing I'm going to want to do is get rid of any powers of a power. We'll get rid of that situation so it's a little more simplified. So we can equate just the bottom if we like. 5 to the power of negative 4 times 5 to the power of 8. And this becomes 5 to the power of negative 6. You can actually think of each of these as being separate multiplication questions. There are technically like 3 terms all being multiplied by each other. And I'm going to show you how you can kind of break this up, these 3 terms. Now you don't have to do it this way, but it'll give you a better understanding of when you have division of several numbers. Okay, 5 to the power of negative 4 there, we can write as a fraction. It would be 5 over 1 to the power of negative 4. Okay, 5 to the power of negative 8 would be 5 over 1 to the power of positive 8, sorry, not negative 8. And the third one would actually be the reverse. It would be 1 over 5 to the power of negative 6.
Couldn't the 5 over the 1 be that too?
It couldn't because it's on the top of the division sign. Okay? And notice this is negative and this is still negative. So let's say I want to turn everything into a positive power. Well, in order to do that, I take these. If I want to turn these into positive powers, I have to invert the fractions, right? So when we do that, keep the original blue. The new ones will go to red in. This becomes 1 over 5 to the power of positive 4. The blue one stays the same. It's still 5 over 1, power of 8. And the other one would be now become the opposite, which is 5 over 1. We inverted it to the power of positive 6. Okay? Now I can easily put these together. Well, actually our bases aren't the same right now, but I want to put them into looking like this again. Okay? Our rules with multiplying fractions here is we just do the tops by each other. So really it's just the 5 is going to be on the bottom, the 5 to the power of 4, because we know 1 to the power of 4 is still going to be 1, right? And so all these 1s, whether we put it to the power of 6, 4, or 8, they're all going to stay as 1s. So the 5s are the only ones really neat to keep the powers the same as. So if we were to rewrite this question, okay, we'll rewrite it in blue, so bring it up here. This now becomes, there's a 5 to the power of the 8 on top, right? It's on the top of a fraction. 5 to the power of 6 is on the top of a fraction. And 5 to the power of 4 is on the bottom of the fraction. And the reason it's on the bottom is this 5's on the bottom here, and these two 5's are on the tops of their fractions. We just keep the same exponents. So what I want you to draw a relationship between is these two things here. Okay? I want you to notice that the 5 to the power of negative 4 is now 5 to the power of positive 4 on the bottom. And let's do it in green. 5 to the power of negative 6 is now 5 to the power of 6 on top. We just flipped them. Does that make sense, that step? Yeah. And then from here, we just equate. Base is the same, so 5 and 8 plus 6 will give us what? 14, right? And we have 5 power of 4. We subtract those two, we're going to get 5 to the power of 10, which is an identical answer. Now, clearly we went about it the long way the second time, right?
Yeah.
But what I wanted you to understand is this rule and how you can manipulate it around a large division question, right? We can keep flipping them out. And I separated it like this, but you could have kept it and gone from this step right to this step. You could have said, okay, the negative goes to the bottom because I want it to become positive, and this negative needs to go to the top in order to become positive. And that's what we did. This 5 to the 6 went on top, and 5 to the 4 went on the bottom. So you really didn't need this part here. That was just to give you some clarity of what we were doing. You could really have just gone, okay, negatives go to the other side. Other negatives go to the other side, and then we work from there.
So I would look at that part as like an equation, when it moves to the other side, it becomes a negative.
Yeah, you could think of it like that, yeah. You just got to go from the top to the bottom of the fraction, that's all.